So what we're going to talk about at this point, and this will be a great segue into your third programming assignment, is to talk about activities in Android. And so as we'll see, activities typically represent a single screen with a user interface, although they don't have to. You can have activities that are headless, I guess is the best way to put it. In fact, you'll write a headless activity for assignment number 3. But the bulk of the cases where activities are used have some kind of user-facing operation, prompting the user for something, displaying something to the user, and so on. Again, if you want to find out more information about activities that goes and gives you another view of this stuff, take a look at the lectures that are here. All right, so focusing on activities with a user-facing capability, there's a bunch of different kinds of user-facing things you might want to do to interact with the user of the phone. And there's typically just one user, because Android is a single user system. So one thing you might want to do is you might want to show a login screen. So when you access Dropbox, it may give you a way to enter in your email or your username and your password. So that would be one kind of user-facing activity-like thing that you could do. You could also read an email message. So here we're going to have a way to read the email message. You might also want to compose a text message or compose an email message. And again, in both cases, it will give you a way to fill in the addresses, perhaps using your address book. You can fill in your subject line. You can fill in the body of the message and so on. And all that stuff would be done inside of an activity. You can use this to view a contact. We'll see an example here not too long from now, maybe on Monday, but maybe later today, that shows how you can view a contact. And in fact, you can actually select from the contact application and then pass the contact you selected back to another activity to process it further. Another common thing to do, browse the internet. You can have a browser come up. You could download and display an image, as we'll see here. Lots of different kinds of things that you can do. These activities are almost always, if not always, launched on demand. And what that means is they don't have to be up and running in order for Android to start them up on your behalf. Now, having said that, as we'll see, once an activity gets launched, then it typically lives for a while until either you click back over it and destroy it, or the system starts to run alarmingly low of memory, in which case it goes ahead and shuts things down by killing activities and services and other kinds of components it doesn't want to keep around anymore. So here are some of the steps. We kind of looked at this. This is just another view of what we looked at before. So the activity will create an intent and call start activity. One activity will create an intent and call start activity, passing in the intent. The Android system will read that thing and then go ahead and create the other activity and call its onCreate hook method, which is basically what's used to construct. It's like a virtual constructor. And we'll look in a bit more detail about all the different steps that are involved in doing this in a second. Here's a typical example of how this works. You can create an intent and pass it to start activity. Here's a case where we're using an explicit intent. Notice here that we go ahead and name the specific class that we want to have to implement this activity. So this is an explicit intent. We're giving it a class name, or it's the name of a class file that we want to have run. So in that case, all those intent filters we just talked about won't be looked at, won't be examined in order to figure out what to run. So as we talked about before, an intent's a passive data structure that provides an abstract description of an action to perform or an event that's occurred, depending on what kind of thing you're using. You can also go ahead and optionally put additional information into the intent. For example, if you're going to do a send multiple, you might want to put a bunch of different email addresses in as extras to indicate what else you want to do. And then finally, after you've built up the intent, and there's other fields you can do as well, you can go ahead and launch the activity by saying start activity and giving the intent, and then the activity manager service looks around and finds the implementation of said activity and gets it launched, if it's not already up and running. Now, it may already be up and running, in which case some other stuff will take place. But if it's not launched yet, then the system will go ahead and launch it. Let's talk about the steps for implementing an activity, and this will be important because this is what you'll have to do for assignment number 3. There's a bunch of different steps that are involved here. The first thing you have to do is extend the activity class. So here's an example. We have, say, threaded downloads activity, which is some activity. And we go ahead and inherit activity from it, or inherit or extend activity to create this activity. And then we go ahead and we override one or more lifecycle methods. You typically always override the onCreate method, and we'll talk more about what onCreate does. It's basically a hook method that creates or initializes the state of the activity. There are other methods that you can also fill in, and we'll talk about what all of them do. These are not as important, or not always used, but they are very important when you need them. And in addition to defining these are called lifecycle methods because they're the ones that are called back by Android automatically to do various things on your behalf to manage the life cycle of an activity. There's other methods you can also provide as well. For example, some methods you do will be connected to the buttons or other widgets on the user interface. So when you click a button, that may end up triggering the handle button click method, which you would write to handle the button in whatever way you want to handle it. And there are other methods you can also provide that do other things. These are probably be called as part of the implementation of these methods that are connected to the buttons and other views. Oftentimes, these methods that are part of this activity implementation implement the concurrent and communication behaviors. And we'll talk about that stuff later. That's the real fun part, learning how all those different kind of things work. And then you also have to make sure that you include a description in your manifest file that says this is the implementation, threaded downloads activity, that's connected to this particular application. So what you're doing is you're exposing this component, this activity, so that other applications that want to use it are able to get access to it. And that's the real power of Android. You can write applications that expose a bunch of different components, and then other applications can come along, as we'll see in a second, and they can use your components to carry out, or you can use either your components or you can use somebody else's components to carry out the application behavior. And that's a very powerful feature in Android. In fact, that's the next subject. Yeah?
Like, for example, if I develop an application and someone else use it, will that be an issue? Because I don't really want other people to use my code.
Oh, great question. So the question basically is, are you forced to expose all your components, your activities and services and so on, to other users on the phone? The answer is no. So if you don't list these things in the Android manifest file, and or you don't list them as being exported, then they're not visible. So you can hide them away if you want to. But, and sometimes it makes perfect sense to hide them away. They're internal classes, they're internal things that you only want to be called by in a very well-defined way that you have total and complete control over, in which case just make them hidden. Other times you want to expose these things because other people want to come along and use them. That's a generally good thing to do because that allows you or others to be able to build upon the efforts that you do. But it's totally up to you and the way you configure the application as to whether things get exposed or not. Now, the other cool thing that you can do with Android is a given application can actually have multiple activities defined in it. And again, there's all kinds of different variants of this. It depends on how coarse grain or loose fine grain or how private or how public you want things to be. Here's a very simple example where we're going to have a main activity which then can make use of a bunch of other activities. And these things can be exposed in all kinds of different ways. Just for fun, we're going to make them all available, but you could have a mix of some things available, some things not available. And these provide different screens for different features. So this screen, for example, downloads an image. This displays the images. This deletes the images. This guy exposes all of these different operations through a user interface. And when you click on them, it goes ahead and calls these other things. And you might want to reuse some of these things to download images in other applications because that might be a useful, reusable capability, and you don't want to have everybody re-implement themselves, that activity themselves. In fact, that's exactly what you're going to do. You're going to implement the download image activity in the next assignment, and that'll be exposed as an activity that other applications could come along and use if they so chose. There's also something called a task, and a task is a runtime chain of activities. And the thing that's cool about this is that the activities that are going to form a task may belong to multiple applications. And this is where the real power of Android comes. because it's possible to write applications that mix and match activities from other applications, and you give the users an experience that makes it look like you've written a special purpose application just for them, when in fact it's mixing and matching reusable components from a bunch of other applications. And I'll show you some examples of this in a second. But the idea here is that you may have different applications with different activities, and a chain is simply or a task is simply a chain of these activities that are being called. And the other cool thing about this, as we'll see in a second, is you can control how these activities in this chain, this task, are managed. And they're managed by something called the backstack. And here's a high-level example, and then we'll show you a mapping onto something that's more concrete. So what you can have is you can have an activity. Let's say starting here, you have an activity, activity 1. It's the thing that is visible. And then as a result of something you do with activity 1, you create activity 2. And activity then goes to the top of the stack. And activity 1 is pushed, in some sense, down a layer. And then you can interact with the user again, and that might generate yet another activity, and that gets pushed on the front of the stack, or the top of the stack. And at that point, a bunch of different things can happen. And then at some point, you may decide to navigate back, which causes this activity to be popped off the stack and destroyed, and then this activity regains focus, and you can go back to doing various kinds of things. So that's a very high-level, abstract view of what's taking place with these tasks and stacks of activities. Here's a more concrete example that comes directly from the inbox. This happens to be Gmail, but the same thing would be true of a mail client that was not Gmail. So here's an example where we've got the Gmail application open, and in this particular case, we're just looking through our messages. So this is some kind of a viewing activity that lets us browse through the messages in our email account, our Gmail account. And at some point, we may decide we want to compose a new message. So you see down here, you click on the little envelope icon, and that will launch a new activity, and that will become the top of the stack. So now we're in the compose activity, and now we can go ahead and we can add in the to field and the subject and the body of the message and so on and so forth, and we could add attachments, blah, 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 all those kinds of things. And when we're done, we can go ahead and click send. And when we click send, that will pop the compose activity off the top of the stack, and now it'll go back to where we were before. So now we're back to the previous activity, which was just viewing our messages. And then if we hit the back button, then that'll go ahead and take that activity off the stack. So we may go back to something else, and that may also go back. So here's an example where, we could have, if we were in the compose activity and we decided we didn't want to send the message after all, we could just click the back button, and that would go ahead and pop off that activity as well. Yes, sir?
What if you were in the compose message activity and then you press the home button? What would happen in that case?
Yeah, so that if you press the home button, that'll go ahead and push that activity on the stack, and that'll be the thing that you're looking at that point. Yeah?
Are all of the changing from activity to activity done under the hood with intents, or is the backstack using a different system to move between different activities?
So the backstack is just popping the activities off of the stack, and so the intents aren't really being used at that point. There are other lifecycle methods that are being used, like on stop, on pause, on destroy, and so on, to control the lifecycle of the activities as they're being popped off the stack or pushed back onto the stack. But the intents are being used to find them in the first place and activate them so they're on the stack in the first place.
Are intents the only way to switch between activities?
They're the predominant way of doing that. Absolutely, yeah. Here's an example that illustrates this, kind of combining both views. So here we have the backstack, and here we have the different application activities. So we start with just the home screen, and then we go ahead and click on Gmail, and then that pushes a new activity on top of the stack, and so we can see the Gmail application just in its default view, which is reading. Then we go ahead and we compose something, and that goes ahead and puts a new activity on the stack, and now we're composing something. And then when we hit the back key, that activity goes away, or we could hit send. Either way, the activity goes away, and now we've popped back, and the next activity that was pinned below the one that was on top of it is now the one that regains focus. And when we talk about the lifecycle methods in a second, you'll see how those things are what determines how the various views get redrawn as the activities come and go. Yes?
You said when we press the home key, the whole activity gets on, goes on. But then when we press back after the home key, it doesn't like off the home.
Well, there's all kinds of different ways to navigate with the various stacks. So a common thing you can do on an Android device, let's see if of course you won't really be able to see this, but I'll describe it to you. Oops. So, here I am on my home screen. If I push and hold the home button, the home button, and I hold it for a length of time, then you can see all the various things that are up and running, all the activities. This is basically the task manager. And I can get rid of them, I can flick them and make them go away, and so on and so forth. So there's lots of different things, and different Android devices handle this behavior in different ways. But there's all kinds of different ways of being able to manipulate the different backstacks and the various activities and tasks that are running in the system at any given time. Yeah?
If you were to clear an application through that, would it affect the backstack? So if you were to...
Yes.
So yeah, if you close the thing, would it take away all of the...
Yeah. Yes, it would clean it up. Yep. OK, yeah?
Can the back be overridden, like in Chrome, if you hit back, it goes back to the page rather than like...
Let's see. You can determine what happens. Those are button clicks, and you can determine how those things are handled. Yes. Yeah.
So you used edit applications in any order you want to, but the stack you like so
Right. So you can basically rearrange and have different stacks be the one that are at the foreground. It won't push them off. It won't pop them off the stack. It just basically makes the home screen the new focus, because you can see that if you hit the task manager view, they're still there. It's just that that's not where the stack currently is. It returns it to the home screen stack, if you will. OK. Let's next talk about lifecycle management. So Android's activity framework calls lifecycle methods automatically, and the secret sauce of this whole thing is this service called the Activity Manager. And it's a very powerful service. It's tens of thousands of lines of code long, very complicated, very cool, does a lot of interesting things. And it's kind of the heavy lifter for all the components, not just the activity. It works for a lot of different stuff. So basically, what this does is it communicates state changes to components, including activities, by calling their lifecycle methods. So let's go ahead and take a look at the life cycles. This is very famous state diagram that you'll see in Android documentation a lot. Keep in mind that everything we're about to talk about, all these methods you see here, on create, on start, on resume, and so on and so forth, these are all called back in the context of the user interface thread. So all of these methods get called back in the one and only user interface thread. And as a result, they can't block or run for any extended length of time. And if they do, if the lifecycle methods run for any length of time beyond, say, 3 to 5 seconds, then the dreaded application not responding dialog pops up, and you'll have to decide if you want to shut the activity down. OK, so the onCreate method, when it gets called, that's sort of the virtual constructor, if you will. That gets called to initialize an activity when it's first created. And it typically does a bunch of things. It calls up to the superclasses onCreate method, passing up some information that can be used to reconstitute state. It also typically initializes any global state in the activity. It inflates, configures, and caches various UI views as needed. And that's typically code you have to write kind of from scratch. And it also is used to set the activity's content view. The content view is the default view that you see when that activity starts. So maybe the content view displays emails from your email inbox. Maybe the content view displays a URL, a place to put a URL to download a file. Maybe it displays something for playing music. Whatever it happens to be, that's the initial view that's the user-facing operation that is shown to the user. Now, so that's what happens when onCreate is called, when something's launched. Once something's launched, then there's a couple of other methods that get called as that activity is getting closer to being the one that's in the foreground. And there's actually a couple of steps here. And they're a little confusing why there are multiple of them, but once you get more accustomed to how Android windowing systems work, you'll see why there are several steps. There's a method called onStart, which is called when an activity is becoming visible to the user, but is not yet the focus of control. This typically resets application state and behavior. And you'll see later that onCreate is only called once, but onStart may be called multiple times. There's also another method which follows after onStart called onResume. And this is called when the activity is about to start interacting with the user. And the distinction that they make is between when something is simply visible to when you can actually go ahead and touch it and play with it. And the reason why they make those distinctions is because it's possible in Android to have windows that partially occlude or lie in front of another window. For example, a dialog box or the application not responding dialog. The background window is still visible, but there's something in the foreground. And so the onResume method is called when you can actually start to interact with the view that the activity is providing. This typically starts behaviors that only occur when something is in the foreground, when it has the focus. There's another corresponding method, which is kind of the sibling to onResume, called onPaused. And that is used when the user leaves an activity, but the activity is still visible in the background. So like when a dialog box pops up, there's a window behind that dialog box, and that dialog box is paused as long as there's something in front of it, but it actually hasn't stopped. It could still be generating something and changing the background if you wanted it to, if you programmed it to do that. The onPause method typically shuts down foreground-only behaviors. Then there's an onStop method. onStop is the sibling to onStart, and this is called when an activity is no longer visible. So unlike the example where a dialog box pops up and partially occludes some background activity, there's another situation where, say, like when you do an email compose, and a new activity starts up and it totally occludes the background activity, the one that perhaps was just giving you a menu of options or showing you emails you could read. When that happens, when an activity is totally hidden, then its onStop method is called back. Its onStop activity lifecycle is called back. And this typically caches any state that may need to be restored when the activity resumes moving to becoming visible. And the key thing to note is onPause and onStop handle different conditions. So onPause is used when you lose focus but you're still visible. OnStop is called when you're no longer visible either. So you can see one is kind of a subset of the other. When something is no longer visible, it's also paused, but you may be paused but not invisible. There's also something called onRestart, which calls when an activity comes to the foreground after being stopped. So it doesn't start over again, it's restarted. And it typically reads any cache state and refreshes the views and other things that are user interface oriented. And then finally, there's something called onDestroy. And onDestroy is the hook method that's sort of like a virtual destructor that gets called back when an activity goes away. And it's used mostly to clean up any resources that may need to be recycled, like writing files to disk or something like that, and then releasing the memory. This is typically called when the user presses the back button. So you hit the back button, and that causes the onDestroy method to get called back, and that's where you can do those kinds of cleanup. Yeah?
So the flowchart doesn't explicitly state that onDestroy is called via process is killed from the memory log, but
yeah, so it'll say that in a second. So it's possible that onStop and onDestroy won't be called in low memory situations. So it's possible for these things to get called back because the system has decided it was too low on memory. Now, back in the early days of Android, when people had a fairly low amount of memory, that was a big deal. Nowadays, it's not as common. OK, so I think we're almost done, and it's almost time for the quiz. Make sure when you implement these things that you call up to the superclass. Otherwise, the right thing won't happen. Yeah?